All right, so what do I do? Well, let's see, this reflection is going to go here, and then it does this. Right. But to be honest, that's not the important part. The important part is you have your representative rectangle, and that rectangle gets reflected up here. And you really want to draw this. I'm going to torture you drawing this here. You won't have to do as much detail after you get the idea, but the only way I know to get the idea is I need you to draw this, and I need you to draw this. And anytime you have something reflected, make sure you do it dashed. And does everybody see our washer? All right. So we're still looking for the washer. Here's the difference, and this is a little subtle, right? I'm going to draw the big radius. The radius goes from the axis of rotation to the far end of the rectangle. Does everybody see my big radius is here? Notice how the big radius had to go down because that's where the rectangle is. You have to draw where the solid rectangle is, not where the reflected one is. And the same thing over here, my little radius is from here to here. Everybody see that? Okay. All right. So now let's do big circle minus little small circle. So the big circle, pi. Our radius is how tall is that blue line? And how you figure out how tall that blue line is top minus bottom. What's the top function? 10. What's the bottom function? X squared. Does everybody see that? All right. Now let's look at the small circle. So if I look at the small circle, pi, okay, we look at this picture, okay, I need to find the height of that tall, I need to find how tall the green line is. What's the top function? Okay, the top function is 10. What's the bottom function? 3x. So I get 10 minus 3x squared. Does everybody see that? Now when we set this up, where are we stacking our rectangles? Again, you look at your original rectangle. Where does that set up from? Where does that original rectangle go from? From where to where? Still goes from 0 to 3. Okay. Does everybody notice in these first three examples, all three of these were going from the integral is still from 0 to 3. Doesn't matter where the rectangle is being spun, where the rectangle is from 0 to 3. Okay? So this is going to go from 0 to 3, and so our final answer for this is going to be the integral from 0 to 3, and like the final answer on a multiple choice question is they would pull the pi out, so this would be pi times 10 minus x squared minus 10 minus 3x squared dx. All right? Now before I do the next stuff, I want to compare. So this was our answer to number 3. And our answer to number 2 was pi integral from 0 to 3. What did I have? 3x plus 2 squared minus x squared plus 2 squared dx. What are the differences? Well, the pi and the 0 to 3 are the same, right? But do you notice that these are a little different, aren't they? Okay? Like notice your big circle for question 2 was involving the 3x, right? but your big circle for question 3 involved the x squared. Do y'all see that? Like your big circle, right, how you get your big radius, isn't always the top function. It hinges on how you draw the picture. Do you see the difference? It's not hard, right? I don't think it's super hard once you realize, because is it hard to see which is the big radius and which is the small radius if you've got a picture? If you don't draw a picture, I don't know how you get it, right? Everything hinges on that silly little red rectangle that we drew and its relationship to its axis of rotation. And so I'm trying to make a big deal about comparing these, that just because you got a function on top and a function on bottom, the function on top isn't always going to be the big radius. And the function on bottom isn't always going to be the small radius. It has to do with where your axis of rotation is. Everybody got it? Okay, those are the first 3 examples. The next 3 go by a lot easier. So next, I want to revolve this around, 3, number 4, I'll learn how to count. I want to revolve this around the y-axis. And so here's our picture. So if I'm revolving it around the y-axis, is it a vertical rectangle or a horizontal rectangle? Horizontal. Because your rectangles have to be perpendicular to whatever your axis of rotation. So I draw a horizontal rectangle. The instant I draw a horizontal rectangle, what letters do I need to be using? Am I using x's or y's? Right? Anytime you draw a horizontal rectangle, you need y's. Right? Meaning you need the other version. Like my answer is gonna, I'll go ahead and tell you, for problems 4, 5, and 6, everything's gonna be in terms of y. And since I want it in terms of y, I need to rewrite this. So what's the rewrite version of this? Solve for x. When you solve for x, what do you get? Are we okay with that? When you solve for x here, what do you get? Perfect, y over 3. Every equation has 2 versions. It's got the version where it's y equals x, or if you got the x equals y. Right? Like this graph is either going to be y equals x squared or it's going to be x equals the square root of y. And which one you use is determined by what kind of rectangle you drew. All right, and so now I draw. We're reflecting, so let's see, this gets reflected over here. This does this, which, to be honest, that part doesn't matter. What does matter is the reflected rectangle. And so now that's going to look like this. Did everybody see your washer, but now instead of your washer being vertical, your washer is flat? And since I'm going to do a washer, I got to do big circle minus little circle. So axis of rotation to the far end of the rectangle, that's the big radius. Axis of rotation to the close end of the rectangle is a small radius. Does everybody see that? All right. And so now we're going to set it up. So I'm going to do big circle minus small circle. So our big circle, here's pi. What's my radius? Look at the blue rectangle, right minus left. What's the right function? Root x. Everybody okay with that?
Or root y.
Root y, yeah, sorry, root y. We need y. So this function is root y minus 0. Are we okay with that?
You do right minus left.
Always right minus left. It's top minus bottom or right minus left. And then your small one, it would be pi. Now let's look at the green one. What's the right function? Y over 3 minus 0 squared. And since that original rectangle is horizontal, and these are all y's, I need to put a dy. And where are we stacking? Remember, we focus on the red rectangle. Where is this rectangle going? From where to where?
0 to 9.
Is everybody okay? 0 to 9? You look at the original red rectangle. See how it's going? And we're dealing with y's, and so the y's are going from 0 to 9. And so this is 0 to 9. And of course, this would be fine on a free response question, but if it were multiple choice, they're going to factor the pi out. So that when they factor the pi out, that's going to give me pi, the integral from 0 to 9. They would actually say this is y minus y squared over 9 dy. Okay. So that's kind of like the simplified version, which is fine, but I want to make sure you understand it's really circle minus circle. Does this make sense? All right? Okay. Everybody ready? So, next one. I've got to erase that. So I want x equals -1. So here's our picture. We still have our lovely picture here. Still the point 3, 9. So if I'm going to revolve this thing around this axis, do I need a vertical or horizontal rectangle? Okay, we're going to need horizontal for the next couple, right? So I draw that rectangle. That's the most important thing I need to do. And now when I reflect that, it gets reflected over here. Does everybody see your washer? I wonder if I should make those dashed. I don't know if that makes it better or not. I don't know if that actually makes the 3D better or not, but all right. So, the big radius, you go from the axis of rotation to the far end of the rectangle, and the small radius is the axis of rotation to the closest end of the rectangle. And with that, we can now do big circle minus small circle. Okay, let's do our big circle. Big radius. Right minus left. So when I look at this blue line, what's the function to the right? Root y. And what's the function to the left? You know, see when I did right minus left, I got root y, and this is minus -1. And then for the small rectangle, this is pi. Now let's think of the small rectangle. What's the function to the right? Y over 3. Okay with minus -1 squared? And where are we stacking our rectangles?
0.
See how those start here, going from 0 to 9? Because we're starting here, we go up there, so this is going to give you the integrals from 0 to 9. This is fine. Oh, I forgot the dx. This is fine for free response, but if it's multiple choice, they're going to factor the pi out, so they're going to say this is pi times the integral 0 to 9 of y square root of y plus 1 squared minus y over 3 plus 1 squared dy. Is this getting incredibly repetitive? Good. Right? The reason I need it incredibly repetitive is it needs to be simple when the questions get at when things look ugly. Does this make more sense now than it did yesterday? Do you see why I put the effort into drawing that original rectangle? Do you see why I put the effort into drawing the big radius and the little radius? If you can see why I'm doing that, that means you understand this, right? Last example. Okay, so we're going to revolve this around x equals 4. I'm going to draw the picture. Let's see, this does this. Here's x equals 4. And here's my experiment. I'm going to hit pause. I draw the rectangle, and I just go ahead and reflect it over here. I really don't care what the whole picture looks like. Here's my big radius. Here's my small radius. And so when I set up, that's going to be pi times my big radius, which is right minus left, and so that's going to be 4 minus y over 3 squared minus pi times 4 minus the square root of y squared dy. And so we get the integral from 0 to 9. Everybody come up with that pretty easily? To simplify it, we're going to pull the pi out, so that's the integral from 0 to 9 of 4 minus y over 3 squared minus 4 minus the square root of y squared dy. Everybody okay? How do we feel about these? A little better than yesterday? I threw a ton of stuff at you yesterday. Now, I want you to see, well, what does this question look like on the AP exam, right? I think that's a reasonable thing. Okay, I've taught it. I said it used to be a big deal. What does that mean? Well, what that means is I probably should have turned the projector on sooner, but it warms up pretty quick. Oh, come on. No, wait. Oh. Let me turn this on. Oh no, it's gonna mess everything up. Please don't, just, yeah. Yay. Yeah, that's everybody that's here. And so this is from 2011. Here, let me bump this up so we can kind of see what's going on. Can y'all read that?
Yeah.
It's big enough, it's just my big tower is in the middle and messes stuff up. All right. So, prime example of this is what it used to look like. They give you a region, they give you these two functions, they define them. So in class, so they define the two functions as f of x is equal to 8x cubed, and g of x is equal to sine of pi x. Right? They don't tell you which one's which, but are we okay? This is the x cubed graph, and this is the sine graph. So you're kind of required to know what each of those looks like, right? Well, think about x cubed has got to go through the origin. It does this, and there's part. All right, part A. It says, write an equation of the tangent line. Shocker, right? How many times have I asked you to find an equation of a tangent line? So that's really not dealing with, anything super tricky, right? Part B, it says, find the area of region R. Well, that's not too bad. Draw your rectangle. Where am I setting my integral up from? 0 to 1/2. Well, drawing that rectangle helps because it's like you know what where your region is. So my integral is going to be 0 to 1/2. All right, what goes in there? What's your top function? The sine one. So it's going to give me sine of pi x minus 8x cubed dx. And if you're curious, I think just setting this up is, I think, worth 2 points. I think you get, usually when you set things up, you get 1 point for the limits and then 1 point for the integrand. How hard was that? That's an easy 2 points. Now, the problem is, to get the third point, you actually have to take the integral and plug stuff in. Do we know enough that that's going to take a lot longer than it was to set it up? So just something to think about. There's certain calculations that if you don't do the final calculation, you don't get the final point. But, and actually, I think you may even get, maybe you get 1 point for this. Yeah, I think you get 1 point for actually taking the integral and then 1 point for evaluating it. I think taking the integral is fine, but plugging in to get the values is a bit of a pain. But next, notice what this says. And I want to make sure everybody in class can see this. It says, write but do not evaluate an integral expression for the volume of the solid generated when R is rotated around the horizontal line y equals 1. Meaning, here's what they want. Here, let me get this back up. They want you to set up spinning that. Is that a hard question now? What do you do? Draw it on the other side. So we draw a reflected here and do this, right? Okay. So here. Let's see what we have. First, let's get our easy point. You get 1 point for the limits. Where are you stacking your rectangle? From where to where? Are we okay? We're stacking it from 0 to 1/2? You got 1 point for that. All right? Now, can everybody see that this is going to be big circle? Oh, I didn't finish drawing. Can everybody see this is going to be big circle minus little circle? What's your big circle? Pi r squared. What's the radius? What's the radius of the big circle?
8x.
Say it, finish. I think you started and you finished. I want the whole thing.
1 minus 8x cubed.
Okay, 1 minus 8x cubed. Everybody okay? That's your big radius? minus, what's your small radius?
One minus
1 minus
sine pi.
sine pi x squared. Did that make sense? Is that easier now? Oh, shoot, I needed to